Hello, my name is Carlos Lopez, and in this project I tested a net battery to see how much voltage could be generated from soil under different conditions. The main idea behind this experiment is that if two different metals are placed into moist soil, they can create a small electrochemical system that produces measured voltage. In my setup, I use copper wire and galvanized zinc, and then I tested how the voltage changed when adjusting moisture, adding salt, and connecting multiple cells in series. So in this video I'm going to walk through the setup, materials, step by step, talk a little bit of my results and what environmental engineering concepts I went through going into this experiment. Okay, here you can see the general setup of the experiment. I prepared 4 separate soil cells, each in its own cup, and used copper wire and galvanized lines as the electrodes. Then I connected the electrodes to a multimeter to measure the voltage. The reason this works is that the setup behaves like a small galvanic cell. The two metals have different electrochemical behavior, and the moist soils act as the medium that allows charge movement through the system. So even though the setup looks simple, it's really demonstrating a real electrochemical process inside the soil. For materials, I use 4 plastic cups, about 400 grams of soil in each cup, twisted copper wire electrodes, galvanized zinc, a multimeter, alligator clips, water, salt. I collected the soil from the arboretum, and I tried to keep the setup as consistent as possible across the cups so the comparisons could be more meaningful. What I like about this project is that the materials are simple and accessible, but they are still allowing us to explore the real settings and ideas from. Let's continue with the experiment. I started with fresh soil condition of the baseline, and I measured the voltage in each cup individually. So we started to take every reading of every cup in every condition. So the first one was the connection in series for the cup, one at a time, to see how the total voltage changed when more cells were combined. So I did a lot of combinations of 2 cells, 3 cells, 4 cells to see how they change. When I tested moisture by adding water in stages, first I created a low moisture, then a medium moisture condition, and then finally a high moisture condition by adding 2 tablespoons, then duplicate 4 tablespoons, then duplicate 8 tablespoons of water until fully saturated soil. And after that, after each stage, I tested all of the readings for the voltage and record everything. I also tested the effect of salt by adding 0.5 grams of salt to each cup and I take new readings for this, so I measure it and I record every step. So with the salt, I wanted to mix really well to have an homogeneous soil, just because that will help us with the readings. And so we took various measurements to each change of conditions, and just to remind you, the main variables we focus on were moisture, soil addition, and the series connection. So now we're going to see where the experiment becomes very interesting, because we can actually compare all of the voltage readings under these conditions. Looking first at the overall pattern, fresh soil average 0.21 volts, low moisture average 0.94 volts, medium moisture average 0.78 volts, and high moisture gives the highest average results at 0.97 volts. The salt condition started at 92 but later dropped to 83 volts. What stands out is more the high moisture produced by the best average performance that suggests that additional water improves ionic movement through the soil, so the soil behaves more effectively as an electrolyte. I looked more closely at the detailed values. One number really jumps out. In the medium moisture condition, cell 4 dropped to 0.35 volts, which was much lower than the rest of the readings. Because that value did not match the pattern of the other measurement, it was most likely caused by an uneven contact cell, or maybe electrode placement or uneven water distribution. So I treated it as a likely outlier rather than the main trend. The salt result was also interesting but less conclusive. Even though adding salt seemed like it might help with conductivity, the later readings actually decreased. So the salt treatment did not create a stable improvement in this experiment. When I connected the soils one by one, the total voltage increased up to 3.70 volts with 4 cells, which clearly showed that connecting the cell density increased total voltage. That's the key is engineering result with this experience. Every cup produced measurable voltage, which showed that the soil and electrode system were functioning as an earth battery. Let's go on with what we have as core concepts here. First, it demonstrates that electrochemistry, because chemical reaction of the electrodes generate electrical potential. Second, it shows that soil can act as an electrolyte when moisture is present, allowing ions to move through pore water. Third, it shows why conductivity matters, because moisture changes how easily charge can move through the system. And it also connects internal resistance, since the soil behaves as a resistive medium and affects the electrical response. Finally, can be related to corrosion behavior, because the zinc containing metal behaves like a sacrificial anode in the system. And one important point is the voltage is not the same as usable power. In this experiment, I measured voltage, not the current or the power of the load. So that's for bigger scale. Like any other experiment, this has some limitations. The baseline soil was not completely dry because it had been collected after rainfall, so that probably reduced the contrast between the fresh soil condition and the moisture conditions. So the soil was naturally variable, so difference in composition, moisture distribution, electrode content may have affected the readings. Also, only one salt dosage was tested, and the measurements were based on voltage only. Even with those limitations, the experiment still gave two very clear findings. Higher moisture improved voltage consistency, and the series connection produces the strongest overall output. So at this point, the main takeaway is that the electrical behavior of an earth battery depends not only on the electrode materials but also on the environmental conditions, such as moisture and ionic content of the soil. To finish, this air battery experiment successfully demonstrated that salt-based electrochemical reactions can generate measured voltage. The most important findings were that single cells consistently produced voltage, high moisture gave the base average single cell results, and 4 cells connected in series reached 3.70 volts. That lies up to less. Overall, this project showed me that soil is not just a passive material, it's moisture, it's ionic conditions that directly influence the performance of the electrochemical system. So we did this experiment. It was useful to connect chemistry, soil behavior, and electrical response to one environment. Thanks for watching. I hope this experiment shows how simple setups can demonstrate meaningful environmental engineering principles. Appreciate your time and attention. Bye.